This is the Year 11 Maths Methods class on the 7th of September 2017.
So what we're going to do is we're going to find the derivative using first principles. So if I put this as x, can anyone tell me what that point might be?
Y.
Yep, it's definitely y. Okay, but if I call that, if I've labelled it as f of x,
I could call it f of x.
yes. So
I was on the money there.
So we're calling it f of x rather than y. Now,
I know she's going to realise that you always bully me.
I'm going to call this x plus h. Okay, so h is some distance across here. Okay, so h is some distance. So if h happened to be 1, if this was, that would be x plus 1. If h was 2 units, it'd be x plus 2. But I'm just calling that unit h for now. So, what would that be?
f of x plus h.
Well done.
On the money.
That would be f of x plus h. So everyone's with me at this point in time? Yep. So if I have this chord, if I call that point A, point B, I want to find the gradient of that chord. Now, how would I find the gradient? Normally, okay, if I put this, what would we normally call that one? If we're doing the gradient, that would normally be x1, that would be x2, this would be y1,
Y2.
y2. So if I had my gradient, we normally write it as y2 minus y1. I'm doing this in green because
Yeah.
we're using f of x's, okay?
Is that a B above that point?
Yeah, sorry. So I've just put this in green because we tend to be using f of x's for this, not really y's, but that helps. So my y2, what's my y2? F of x plus h. We take away y1, which is my f of x. I'm going to do my x2. I'm going to leave it in the brackets for now, minus x. So we know each of those points. So if I take those brackets out, leave these ones in because that's the function. I'm going to get x plus h minus x. X take away, I'm going to be left with h up the front. Okay. So this is my gradient of the chord AB. I don't know what my function is yet, but that's our general statement there. Everyone follow along with that?
Wait, why is it 2 again?
Why is it?
Why? No, it looks like 2. Yeah, it's alright. I got a little confused as well.
There we go. There we go. Sorry.
Plus h. Why is it f of x plus h?
Okay. So if this was 1, yes, and h was 1, then that would be 2. So I would sub in f of 2. I would sub in the value of 2. Yeah? Does that make sense? So whatever this value is of h, so if that was 1 and that was 1, then that would end up being the value of 2. So I'd have to sub in 2 into my equation. Yep.
What if that's in there? Can you like simplify that more and like get rid of the f of x and the f of x?
Not until I know what the rule is. What I know the rule of the equation is.
Okay.
So f of x is this equation. That might be x squared plus 1. It might be... So we can simplify it.
Yep.
But I don't know what my function is yet.
Okay.
Yep.
Yep.
Now, this is where... This is an average, isn't it?
Yeah.
Yep. This is an average from what we did the other day. Tell us next. This is an average. So if I get this down here and make h smaller and smaller and smaller, what's going to happen if h becomes really small? It'll be accurate, and what are we calling that?
Instantaneous.
It's instantaneous, and what do we call that line? Tangent. It's going to be the tangent. So
Bags on the board.
we would actually get the tangent. So our chord, if we changed our chord to a secant, so the secant
It's keeping me captive.
we've got A and B. The secant, which is our line. Okay, so if I extended this line, okay, and became a secant now, so the secant between A and B becomes the tangent as h becomes smaller and smaller. So we get the instantaneous rate of change. Now we have a mathematical way of saying that h is going to get smaller and smaller and smaller. We say the limit as h approaches 0 of okay, that's the instantaneous rate of change. And we actually call that f dash of x, which is called the derivative.
Wait, that's not even. It's limbo.
Okay.
Limbo. It's limbo.
So you followed me with this.
So what? That's the limit. Of
Okay.
H, is that what it means?
So this is saying, you agreed with me that it's as I make h smaller and smaller and smaller, okay, it's going to become the tangent and the instantaneous. But if h is underneath, can we have 0 under here?
Hey?
We can't have 0 under there because it becomes undefined. So this is why we say this.
So what does lim actually mean?
Limit.
Limbo.
Yeah, I'll explain. So, this is a way of saying h can't be 0, but it can be really, really small. Mathematically, we write it as this, and that's what it says. That's how we say that.
Oh, okay. Limit.
So, h can't equal 0, but it can be really, really small. And this is what this means. H can't be 0, but it can be really, really small. Mathematically, we write it as limit as h approaches 0. Yeah?
Could you just write h is greater than 0?
No. This is a specific mathematical for part of finding the derivative. Yep. It's specific mathematical language for this problem, for these types of problems, which is differentiation of first principles. So there is no shortcut for this.